Evening, sir. Hi, students. How are you?
Pretty
Yes,
good, sir.
Good, 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 good. Um, so I'm hoping that you would have been able to get an opportunity to look at this today, and maybe not because you're at work, I maybe not be able to get the time. So this is why I projected this stuff here, hopefully to give you these 40 minutes to jumpstart the question. So my question is, have we completed 2010 May question that is being projected?
just got in, sir. I'm attempting it now.
You're attempting it now.
Yeah.
Mari, how is the Sean?
I just finished it, sir.
You just finished it. Simon, how are you?
Sir, I'm at number two, near
Yeah,
the
number
end of the simultaneous, but I'm not really optimistic about it.
is all right. It's 50 marks for that number two. So try to get your optimism up. This is the last question I'm doing on this thing. I don't have any more questions on the thing to give. I'm moving into something new tonight. Um, Let me ask a question while you work. Do you recognize anything with this question? All right, no answer. Go on work. Let me give you, it's now 6:40. I'm gonna give you say another 7 minutes. And then we move on into some other stuff. Another 7 minutes, all right? Are we finished now? All right. Simon, are you finished now?
Yes, sir.
Let me see who the ones that are here. Us four still. All right. All right, Simon, what did you get for the first part of the question?
Sir, for number 1,
Mm-hmm.
I got 19 million.
Tamari, agree?
I agree.
Mm-hmm. And I know Mr. Shep would agree. Tamari, what you got for number 2?
The stationary point is 3,2.
So therefore it is. It is here for what?
I'm not understanding, sir.
No, but I mean, remember what the question says. The question says that it's in what?
Millions.
Mm-hmm. So give me the final answer now.
Or the minimum cost that they should spend each year on each activity is 3 million on labor cost and 2 million on material cost.
Thank you, sir. Simon, what say you? You agree?
Yes, sir.
Mm-hmm. Chevy, Chevy, Simon, what you got for part 3?
Sir, I didn't get to complete it, but I'm guessing 20 million.
Okay. Shamai, what you get for part 3?
Yeah, I got 20 million as well.
Chevy, what you got for part 3? It's not here. All right. I didn't get 20 million for part 3. All of it got 20 million. So you got the 90 million. You got your simultaneous equation. You got your stationary point to be 3,2. So therefore, $3 million should be spent on annual labor cost. $2 million should be spent on annual material cost. Oh, this is the 20 talking about?
Yes, sir, that 20.
That's not it, man. That's not the 20 for part 3. See, that's still part 2, you know. Talking about what is the minimum cost.
Or we should have plugged in the stationary point into the
Thank you. Into the function. So plug in the stationary point into the production formula. So the production function here. So the stationary points, you can put in that. So do that in 2 minutes, Rona, please.
Oh, sir, that's it. Oh. Oh. You know what I'm saying?
Just remember that the value of D here is just to classify the nature of the stationary point. So that 20 is not what it's supposed to be. All right, do that quick and fast for me, please.
So, sir,
Yes, sir.
all right, Michael. For question 2, we don't require us to do up to the critical points, the 3 and 2, sir. We still have to do the D, find D.
Yes. Fine, D. Yeah. I'm going to explain why. When I finish, I'll explain why. I don't want to tell you no, because sometimes how the questions are worded, it will require you to do it. And I don't want you to miss it, not do it, and you don't get a mark. If it's what I'm saying. If you do it and it never required, at least you won't lose any mark. And what I'm training you for is to pick up full mark. This is a 20 marker. A question like this can very well come out on the exam. You do the first question on the exam and get a full 20 out of 20. You're on your way in passing. You follow me, I say?
Yes, sir.
Mm. All right, so we'll finish that now. Tell me what to get for the answer.
12 millions.
12 million is correct.
Yeah, same.
Shamari, we good.
Same thing, sir.
Mhm. Very nice. So 12 million is correct. All right. So the question would have said, determine how much per year should be spent on each area in order to minimize cost, and show why this cost is a minimum.
Also, that's
No.
why I didn't show what.
Right. Show that the cost is a minimum. Is when you do all of this, you show that it gets a relative minimum. You follow what I'm saying, Papa?
Yes, sir.
Let me go again. It says, and show why this cost is a minimum. So you have to do that. But remember, parts, come in if you get 12 million, Parts, come in if you get 12 million. So you have to show that the cost is a minimum. So showing that the cost is a minimum is when you're classifying the nature of these turning points, the 3 million and the 2 million respectively, for labor and material cost. So when you go ahead and classify it now, you get the minimum. So yeah, boom, suggesting that we have a relative minimum. So you do get marked for this show. And should be told, 4 lines, 3 lines, 1, 2, 3, boom, done. All right. Now, I want you to assess honestly where you're at. If you think you're understanding what is your level of maturity with this topic.
Sir, for me, it's just the simultaneous equations.
Okay. So it means that you need to grab a few simultaneous equations and go and practice on those, because the topic is coming. I'm not going to go around you. It's going to come. I'm not go around you. Chevy, Shamari, how we stay?
Sure, all right so far, sir.
Good job. Shamari.
Feeling good about it, so I can do it mostly without looking back on a question.
Very nice. Very nice. Very nice. All right. Do me a favor. I want you to. We're moving into something new. I'm moving into some Hessian Matrix. Yes, some matrices. And the matrices that I'm looking at now is on the multivariable functions. This topic is easy. At first, it may give you a little issue to assembly. I'm starting and finishing this topic in class tonight. Matter of fact, it is my hope that by 8 o'clock I can finish this topic so we can move into something else. So I'm going to ask you to just read through. You see this MMMO business? Ignore it from the please. I don't know where it come from. I just saw it a while ago, and I don't know if I was preparing the document. I don't know. Just ignore the MMMO for me, please. What it should be some 3 dots like these here, pointing downwards. I don't know what happened. I'm giving you 5 minutes to read through and try and understand as much. The multivariable functions that we've been working with are functions in just x and y. You recognize here that this one now is x, y, and z. Don't worry about it. 5 minutes starting now. 10 past 7, I'll come back to you. how we feel. Talk to me.
H of X, H of H, subscript F.
Say it again, Papa.
This is the H of X, H, F, H, subscript F. What are those?
All right, cool. All right, no problem. Thank you for asking. All right, so what is happening now is you're talking about the A11, A12? Or are you talking about H of F, and H superscript, subscript F?
Yeah. The H
Okay.
and H, yes, sir. That one.
Okay, it's just how you name Chevy, and how Shamari name Mary, and how Simon name Simon Peter. It's just a naming of it. So we have different, when I say different authors, it's just different names. How we name them. I can name it H of F, H open bracket F, or I can not put the bracket and just call it H F, or I can call it H subscript F. Follow me?
Okay.
So any of those conventions would be correct. Any of those conventions would be correct. So just giving a little heads up as to that. So yeah, some people call it Hessian Matrix, some people call it the Hessian Matrix. So it's, some people say pronounce Hessian as Hessian, Hessian, whichever one you want to pronounce it, just make sure you can spell it. And when you see it, you know, says it I'm talking about, right? So the Hessian matrix of a multivariable function FYZ with different authors, and I just explained what those authors meaning. Authors meaning really are the names of how it is that we're going to be naming our matrix. Organizes all second partial derivatives into a matrix. So it's only second partial derivatives that are going to be ordered in this particular matrix. So I want us to examine a 3x3 matrix. A11, A12, A13, A21, A22, A23, A31, A32, A33. What do you think I mean by A11, A12, and A13?
Row by column, something like that.
Yeah, but I mean, what do you mean by row by column? Give me, be more specific.
All right. A11,
Mm-hmm.
first row, first column.
Mm-hmm.
A12, first row, second column.
Mm-hmm.
And A13, first row, third column.
All right, very good, excellent, right? So good. And then A31 is going to be the third row, first column, and
Yeah.
A33 is going to be the third row, third column. Very good. So each of these, what we call entries or elements, is specifically placed in a matrix. So in this 3x3 matrix, A22 cannot go anywhere else but in the second row, second column, because that is a position of that matrix, right? So the position of the matrix tells me where the element or the entries are to be placed. All right. Now we're going to be looking at this 3x3 Hessian matrix. And I want to just go through the matrix with you so that you can see what is happening and how it is that you can go ahead and write this 3x3 matrix. Let me just pivot and say to you that they can give you a 3x3 Hessian matrix in the exam to do, or they can give you a 2x2 Hessian matrix to do. All right. So the Hessian matrix could be a 3x3 in an exam. It could be a 2x2. So the 3x3 matrix would be about 10 marks because you have to write all these 9 stuff. The 2x2 matrix may be about 5 marks because, of course, it's a smaller matrix that you have to work with. So it depends. So let me just pause and say something to you here. So if they give you a stationary point multivariable function to do, and that is a 20 marker, I expect them to give you, well, if it's a 20 marker, them can get a Hessian matrix to do for another 10 marks to make up for the 30. It's a good filler question. That's the point I'm making. What is another good filler question is Maclaurin's expansion. The questions normally come for about 10, 11 marks of Maclaurin's expansion. You know what is also a good filler thing? Newton-Raphson. Very good filler something. You know what is a normal good filler question too? Trapezoidal rule. So you can get 3 parts of a question. Them can give you Newton-Raphson for 10 marks. Part A, part B, them can give you Maclaurin's expansion for another 10 marks. And part C, them can give you a trapezoidal for 10 marks. And them 3 something there give you a full mark question. It is possible. And then them can just jolly well go ahead and give you, this is what I'm saying to you already, you're supposed to can do the exam. Because if them ever make the mistake, and then they made a miss. If them ever make the mistake of saying, let me give them a multivariable function for 30 marks. And let me give them a 3-part question. Trapezoidal, Maclaurin's, and Newton-Raphson. Tell me if I'm not straight A, you get right there, sir. True or false? No, and yeah, man. Easy 1, 2, 3. Easy 1, 2, 3. We don't even come in the Hessian matrix yet. And I'm sure when I finish with this tonight, you're going to tell me, say, boy, sir, yeah, man, it's doable. Right? And there are some other little things that I need to present to you that I know it's going to be doable as well. All right, let's go. So, Chevy say, yes, sir, think row and think column. Think row, sir, and think column. All right. When you say ABC, which one come first? X, then Y, and then Z, don't?
Yes, sir.
Yes, sir.
Oh, watch me now. You notice it in here, so you have the X them in red, talk truth. Which one of the variables you have in every one of these here, so? X. Which one of the variables you have in every one of them here, so?
Y.
And which one of them you have everywhere down here, so?
Z.
Good job. So you can see that? In my first row, I have every, you notice, I should say, what do you notice in the numerators?
Just D squared.
Oh, sorry. It's actually not D. It is squiddly squared F over squiddly X squared. Squiddly squared F over squiddly X squiddly Y. Why, sir, you call it squiddly? Because these are partials. It's not a full differentiation, so we don't call it D squared F by dx squared. These are partial derivatives. So that's why it looks like a D. It's not a sexy D I was writing. It's just a partial D. So we call it a squiddly D because it is just, or me call it a squiddly D because it is only a partial derivative that we're doing. Remember, when we're doing the multivariable function, is a partial differentiation because if we differentiate in respect to X, we now touch Y, don't it?
Right.
Yeah, so it's a partial derivative. So don't make the mistake and say D, because we ain't write it like a D. It's not a D, it's a squiddly D. Squiddly because it's not a full D, but it can sit one look like one D. You know, like when you go someplace, sorry, you know, like when you go foreign. I had an experience last summer. We're catching other people them place and thing and with the road I walk up and down and I said to my mom, are you hungry? Because them walk with them bill in them hand. I said, are you hungry? Everybody say yes. Me could have gone still, you know, but them say them hungry. I said, all right, let us stop. I said, what do you want? She look up Jamaican food. I said, miss, you're coming from Jamaica. Why would you come here to buy Jamaican food? Because you don't trust the other food. I said, well, you're going to be here for quite a while, so you have to go eat it. No, I want Jamaican food. Your wish is my command. I said, which of the Jamaican stores you want to go to? And she selected one. And she looked at the food. I said, what you want? She said she want the current goat. I said, okay, fine, bought the current goat. Lord, it don't taste good. I said, but this, how you expect the current goat to taste good in foreign? When you want current goat to go in your yard, go cook current goat back home at Jamaica. So the point I'm making is, it's not a complete cooking of the current goat, because the current goat never looked like curry at all. It looked like brown stew goat. All right? This squiddly F is a partial derivative. Just like the curry goat there, so it never finished cook. Well, it is cooking up, but it not have the curry goat taste. All right? This is it. When I have the D squared F, you know, it's a complete differentiation. It's a single variable function. When I have the squiddly D, it is a partial derivative. All right. So I'm going to point out now, so now that you know that the numerators are the same in every one of them. Can I say that?
Yes, sir.
All right, good.
Yeah.
Now we just need to work out what the denominator is going to be. But now you also know that in the first row, every one of them have X. In the second row, every one of them have Y. In the third row, every one of them have Z. But I said something just now. In the first row, every one of them have X. Which one started?
X.
Very good. In the second row, every one of them have?
Y.
Which one started?
Y.
The last row, every one of them have?
Z.
Which one started?
Z.
All right, good. And watch me now. When you're doing your simultaneous equation, because a week's a bright, now we're going to just do this thing one time. And all the time for go for Lily and go one like go take a little time to learn something. Let us look at the simultaneous equation. What do you recognize with let us look at this one up here. What do you recognize with these two equations? Tell me how them arrange. Look at them and tell me how them arrange. If you can tell me, it will be easier for you to see it. Equation 1, equation 2. Don't matter look on this negative 2. Just look at these two equations here. Tell me how they are arranged. Describe them for me.
X plus Y equal constant.
X plus Y equal constant. All right. And what on your side again?
X plus Y equal constant.
Okay. So what happened? What when you look at the two of them together now, what you see? What you notice?
That the lineup,
What line up?
the X's, the Y's, and the constants.
Very good. So the X them under each other, don't it?
Yes, sir.
And the Y them under each other. All right, good. All right, good. So I just want to see. I don't want to know. All right, now watch me. So in the first row, have what again in the first row? And the second row?
Y.
Third row?
Z.
The first column is?
X.
The second column is?
Y.
And the third column is?
Z.
Good. So in the first column, every one of them have one X. I'm going to put it in a red. In the second column, everyone, because you're lining it up, you know. You're lining it up just like we just showed the simultaneous equations a while ago. The X them on the one side first, then the Y them on the one side after, then the Z them on the one side after, right? So we always start with the X them first. So X, so, and so. Can you see that? Watch it
Yes,
again.
sir.
Watch your cursor again. X's go this way and that way. The Y's go this way and that way. The Z's go this way and this way. Follow me?
Yes, sir.
Good. So in A11 position, you will have X and X. Oh, you know that, sir? See that, sir? You have 1, 1. Then you go down to this diagonal, you have 2, 2. You go down to the diagonal again, you have 3, 3. So if this here goes so, it's all X's. See here? 1, 1, 1. All X's. And go down so is all X's. Oh, you know, sir, see here? So 1, 1, 1. That means this is going to be X and X. I'm going to give X squared. So it's going to be squiddly X squared. You know, say Y is going to be the second one. See here? So after X, then come Y. So this is going to be xy. Because if x are 1 and y are 2, it's going to be xy. So squiddly x times squiddly y. See here? Squiddly x times squiddly y. And z now are going to be the third one. Watch it. See here, so? X is the first. So you may wonder what I talk about first, second, and third. X is the first, y is the second, and z is the third. So will they always be arranged like this? Yeah. And then now you can have 1 and 3. 1 and 3. No, x and z. So that means that it's going to be squiddly x, squiddly z. Squiddly x, squiddly z. This a 2, 1, 2 a y, and then x up. But sir, we know say everything got crossed in the second row a y. Good. So squiddly y, squiddly x, squiddly y, squiddly x. Squiddly y. But sir, squiddly y is just squiddly y squared. Yes, squiddly y squared. And it's going to be squiddly y, squiddly z. Sir, how you know that this is squiddly z again? Z is the third one. So squiddly y, squiddly z. See here? Squiddly y, squiddly z. And then this now, the third one is z, but the first one is x. So squiddly z, squiddly x. See here? Squiddly z, squiddly x. And then we can have squiddly z, squiddly y. Squiddly z, squiddly y. And then the 3, 3 now is going to be squiddly z, squiddly z. And squiddly z is the same thing as squiddly z squared. Does that make sense?
Yep.
Do you think now, on your own, you are able to write this 3 by 3 Hessian matrix?
I'm not able to draw that squiddly thing there, no, sir.
Brethren, look at just do so and come so. Just do so. Watch a screen. I don't even know if I can. Let me see if I can. Sorry. All right, I was doing something before the class start and I got distracted. You remember the other night I had a problem writing my tablet. Immersive reader. It's not immersive. No, it's immersive reader. Yes, it's immersive reader. No, but it's immersive reader. It's on. No. So I need to close immersive reader. All right, so I close the immersive reader, but oh man, there is something preventing this document. I know I converted all of them, you know. All right, so I had the immersive reader open. I closed it, but it is, hold on. Oh, seminar smart. Oh, seminar smart. Watch this now, Papa. You come so, you hold it so, and you come so. You start so, you come so, and you come so. I'm using so it's just a squiddly thing. It's not, what I don't want you to do is write it as, sorry, I'm not using the tablet itself, the writing pen itself rather. I'm using a keypad. What I don't want you to do is to write a D. It's not a D. So if what you want to do, if you want to do, don't carry it all the way up, carry it across to show you that's a partial derivative. Make sense?
Yeah.
Yeah, man. And it almost looked like a backway 6, if you ask me to. Okay. And remember now, squiddly x squared is the same thing as squiddly x, squiddly x. Squiddly y squared is the same thing as squiddly y, squiddly y. And squiddly z squared is the same thing as squiddly z, squiddly z. All right? Okay, so let's go. This is where the tire meets the road. Let's go. Ay, don't do that to the storage show. Oh, man. Oh, jeez, the thing freeze up on me a while ago. All right, let's go now. All right, let's go. It says for us now, for example one, to compute the Hessian matrix for, ouch, to compute the Hessian matrix for the function f of x, what? Then, sir, you really just go through the 3 by 3 matrix a while ago with it. And then the first question, I will give him one 2 by 2 matrix to do, sir. Sir, I mean, really, they are expect one 3 by 3 matrix. Count your blessings and name them one by one. This was specifically done because I want to see, now that you know how to write the 3 by 3 matrix. I did that so that you can demonstrate for me how to write the 2 by 2 matrix, the 2 by 2 Hessian matrix. 2 rows and 2 columns. And you can't just say, sir, we're just going to use these things up here. No. Go ahead for me, write the 2 by 2 Hessian matrix, and then I'm going to give you about, let me give you 5 minutes, because since you're just learning, I'm going to project. Let me go back. So what I want you to do, because I'm going to go all the way up, I want you to write, this one only says f of xy. It didn't say x, y, and z like up here. So because it says xy, it means that's a 2 by 2 matrix you're supposed to write. So let me project everything that I have up here and ask you now to go and write for me the 2 by 2 matrix. The Hessian 2 by 2. 5 minutes. If you finish before the 5 minutes, just let me know. OST. You get it? Hmm?
All right, sir. All right, so like what the numerators are the same.
Mm-hmm.
Can just say that what for denominator.
Yes, man. That more I do. Yeah, man.
All right.
Good evening, sir.
Hi, Mikey.
All
Go
right.
ahead.
So squiggly x square. I'm doing the first row.
Mm-hmm.
All right, the first row, second column, it is squiggly x, squiggly y.
Mm-hmm.
Second row, first column, squiggly yx.
Mm-hmm.
No,
Squiddly Y, squiddly
squiggly
X.
Yeah, yeah.
Mm-hmm.
And the next one is squiggly y square.
Very good. Shamari, that's what you got?
Yes, sir, that's what I got.
Good job. Simon, what you say?
Yes, sir. That's what I got.
Good. So it's supposed to be squiddly X squared, squiddly X, squiddly Y, squiddly Y, squiddly X, and squiddly Y squared. Very, very good. Very, very good.
Sir,
Yes, please.
can I explain this one, please?
Mm-hmm. All right, just give me half a second. Just watch what is happening here, and then I'll go through again. All right. So this is what it is that we're doing here. So we're computing the Hessian matrix for the function f of xy, which is going to be, and this is a function given, and we're evaluating at the point f of -1, -1, +1. All right. So remember now. So when we look at this here, f of x, y, and z is suggesting that we have a 3x3 matrix. In this here case, it is suggesting that we have only a 2x2 matrix. Now, let me say it again. For the exam, you may very well be given a 3x3 matrix, or you may be given a 2x2 matrix. Now, look how easy it was for you to write the matrix for the 2x2. So the truth of the matter is, you get a mark. You get marks for writing the matrix because the matrix is not going to be given to you in the exam. So I have to credit you for the marks, for the knowledge of writing the matrix. All right? Now, look at what is going to happen because I did this question for you. You see the function? It says f of xy is equal to 5x squared plus xy cubed minus y squared. Now watch me. Let me jump. Don't look at anything else. Just look at just look at the matrix. Just look at the matrix. So you're correct. You notice right up here, so I use this notation, h of f, and down here, so I use h subscript f because I want to show you that it means the same. The notation means the same. All right? Now, so this is what they were talking about, Mikey, and this is what you should have it should look like. I know you're ready to me, but this is what it should look like. Squiggly square f over squiggly x squared, squiggly square f over squiggly x squiggly y. The x comes before the y. But sir, does it make a difference? You'll recognize that. Let me ask you, does squiggly x squiggly y makes a difference with squiggly y squiggly x? If yes, tell me why. If no, tell me why and give me an example.
I don't think it make a difference, sir.
Okay, why?
It's just like when we're doing the f of the f of x, y, and the yx, it's the same thing. The same
Excellent.
concept.
Good answer. Very good answer. So the squiggly x squiggly y and the squiggly y squiggly x actually is the same thing or should be the same thing. So when you're doing a calculation, notice the leading diagonal has the squares inside. The leading diagonal has the squares inside. Notice here, when I draw a line, oh goodness, you know, I should be able to draw straight lines into this thing here. I should be able to draw straight lines into this thing here. but I don't want it so. I want this to be rotated. All right, take this thing, you know, Jesus. All right. So what that is showing it is the is my leading diagonal. My leading diagonal is here. All right. Now what I wanted to do, see if
Also, that's a stencil.
yeah, but it
The 45 like it's a TD something else.
yeah. Yeah, but all right, so I'm not in a good teaching position, and I'm sure so tomorrow morning I'm not gonna able to wake up because I have a pain. All right. Yeah, it is a stencil, but I should be able to to
So are you using a mouse like a with one with a scroll wheel?
no, I'm actually using the a keypad, but I should be able to do something here with on the inside because all of it down there, if I scroll all the way up, it's just measurement you can see right there. So any movement will have to be from inside there. I just need to raise the red something, but it's not giving me the anyhow. Now we have the time to figure that. This is something that I need to. All right, let me just try this here. That's not giving me what I want. Let me just draw it and show you something. No, let me highlight it. Can you see that those? Oh no, that's not a good thing. You know why? Because
Why?
the Y is the same color. So let me use this now. Don't use that neither, Shan, because I've been reading this too. So use the purple. The point I'm trying to make is, you see that line right there? So you see, so the X, Y, and the Y, X are the same thing. Talk to me now.
Yes, sir.
Good. You see the Z, X, and the X, Y, are the same thing.
Yeah, yeah.
Yes, sir.
Them are the same thing, don't?
Definitely.
Good. And then of course you know that the leading diagonal is going to be the squares. So what I'm saying to you is that if what Maggie said is that squiggly y, squiggly x, and squiggly x, squiggly y means that when you put it in a matrix, this value and this value can be the same. If what he says is correct, and we will prove whether or not he's right. Squiggly z, squiggly x will be the same as squiggly x, squiggly z. And I mean, this will also help you to write your 3x3 matrix, should in case I give you a 3x3 Hessian matrix do. And squiggly z, squiggly y is supposed to be the same thing as squiggly y. So the value here and here is supposed to be the same. The value in this corner, value up in that corner is supposed to be the same. This value is supposed to be the same as this. The values in the middle are supposed to be all different because those are squares. All right, let's move on. So let us look now at I hate when this thing freezes up on me, see, and I notice every time I use that stuff, it freezes up. All right, let's go. So we are saying that these two here supposed to be the same. All right, so let's go. So what I want you to do is just to get your practice, because it's still the same, is the same thing. I want you to find f subscript x, f subscript xx, f subscript y, f subscript yy, f subscript xy, f subscript yx. The same 6 calculations that we normally do. I want you to go do them right now. I'm not showing you them because I know you know them. On the mark, get set, go. I'm giving you 3 minutes because you know how to do this now. Do the 6 partials for me, please, quick and fast. Remember, we're finishing this topic tonight and not coming back to this topic. It's not a hard topic. You know how to do the partials. All that I must teach you tonight is just to put it into the matrix. And we're almost at that point now. Thanks. How far are we? We finished we finished the partials yet?
Yes, sir.
All right. What do you get for f subscript x?
I got 10x plus y cubed.
And what you got for um And what to get for XX?
Got 10.
Do you all agree with him?
Sir.
Um, um, Simon, what you got for F subscript Y?
Sir, for X subscript. Sir, F subscript Y.
Mm-hmm.
Sir, 3XY square minus 2Y.
And what do you get for YY?
Sir, 6XY minus 2.
Do you agree with Simon?
Yes, sir.
Chevy, what do you get for XY and YX?
3y square, both of them.
Do you agree with him?
Yes, sir.
Yes, sir.
All right. Okay. So is hold on a minute, please. So all of you are correct. And I'm so excited because you guys got it. Let me resume my share and show you what it is. You have it. And I'm saying to you, please don't disappoint me. I beg of you. Don't disappoint me. Those of you who are struggling with the editor soft, those who promise to start this weekend, I'm looking forward to seeing work done up. Just complete your editor soft. I did promise you next week for the mid-semester. When that comes, shut it. Try and go into the exam with a good percentage, so you at least feel comfortable. And when you go into the exam, when I'm marking the paper, let me feel like I'm marking bachelor students' papers. Please. I'm going to go do no question and do the stuff because we don't have it. So since we only have two variables, X and Y, we will end up in a 2x2 matrix. And the SI matrix is given by that. We have that. All we now need to do, you say squiggly square F by squiggly X square is going to be what? What value go right here? So
It's there. Okay. X.
What goes here? What goes here? What value goes here?
10.
Yeah, very good. What value goes at xy?
3y squared.
What value goes at theirs? All right, I have it. I went all the way up and you would have seen it. So y is going to be 6xy minus y squared. So this is my matrix. So that's what I was saying to you when Simon says, not Simon, yeah, when Simon says it's supposed to be the same, yeah, it's going to be the same. So you plug in your values for the matrix here, so. And then now they gave you the point -1, 1. See here them say at the point -1, 1. So anywhere you see x, you put -1, anywhere you see y, you put 1. So this is going to be 10 remains as is. This is 3y squared, then become 3 times 1 squared. See it right here, so. Again, 3, same value here is the same value there. And this is going to be 6 times -1 times 1. See it here, so, minus 2. And when you work it out, you can get 1 squared is 1. So 1 times 3 is 3. I have my 10. So this 3 is the same as this 3. -1 times 1 is -1. -1 times 6 is -6. -6 minus 2 is -8. There goes my 3 by 3 matrix. I mean, my 2 by 2 matrix. Yeah.
Sir, can you scroll back up, please? Sir, normally the X don't come before the Y because I see you have, you can scroll back down a little bit. Scroll back down where the -1. All right, so the -1 and the 1, normally it wouldn't be the X come before the Y.
Mm-hmm.
But I see where I like the green, the -1, you have it as Y. I'm not. Hold
The
on.
negative, the negative, the x is going to be negative, the green, and the y is going to be red. No?
Oh,
The rest of
yeah,
you,
I see,
am I correct, the rest of you?
I see it, sir. I see.
Okay, yeah, man. So it's only one x I have really, and that is going to be this here, so it's only one negative. It's only one -1 I'll have, and I have that in green, and see it right here, so.
Because what was confusing, all right, so we have, so it's a no at the point. If normally it would be x, x then y in the bracket.
Mm-hmm.
But this one is flip, is y and y then x.
What is flipped? I'm not following you.
Right. All right, sir. So if x and y would normally be in the bracket, right? So the x now,
Right, you're
yes,
talking?
yes, sir. So the x would normally be should be the green, the first one.
And it is.
No, sir, but on that me see your highlight. You have the first one as you highlight it as green above that. The Y, the color code. Sir, the color code, sir.
This?
Sir, look at the color code. Yes, sir. That should be X, right? But look at the color code that you have above it. The H of
Up here,
X.
sir?
Look at the lower one.
This?
Yes, sir. You have that as Y.
No, man. No, hold on. You mix it up, man. You notice I kept this here so as red for X and this as Y. So this has nothing to do with this. So don't look at it. Don't look at up here, so. And maybe I should use different colors here. Don't look at it up here. So this is just my matrix. What I'm substituting these values here is a substitution of these values down here, so. So maybe I should have used a different color other than red and green right here, so to show you that there's a substitution that I'm doing here. This up here, the matrix, is just following from the values that I'd used up here, so. X, Y, and Z, I use my red as my X, my Y as my green, and my Z as my blue. So because I use it like that up here, so, I was following through with it down here, so. So what I should have done is to use a different color here, so, for the substitution down here, so. But this -1 in green and in red 1 is the substitution for down here, so, not up here, so.
Okay, sir.
Yeah, and in any event, I'm not substituting, I can't substitute anything here, so, because this is just a matrix that I'm going to substitute. So this squiggly y, squiggly x is going to be 3y squared. See? Squiggly y, squiggly x, squiggly y, squiggly x is also partial derivative of xy. So theta is 3y squared. So I can't do any substitution for these in any event. This is just to get my partials, which is up here. So my f of xx is going to be squiggly x squared right here. So that's why I have 10 in this position here. So, all right. And just with that, right. That's why I have the 10 in this position there. So when I have squiggly x, squiggly y, you said it. Squiggly x, squiggly y is the same thing as squiggly y, squiggly x. Both of them are 3y squared. So that's why this and this is going to be 3y squared. See here? 3y squared, 3y squared. And then my squiggly y squared is going to be right here. So 6xy minus 2. So that's why I have the 6xy minus 2 right here. So, and then now the point is going to be -1 for x and +1 for y. I'm looking at those values inside here, so to make the substitution in here. Got me?
Yes, sir, got it.
Good. So now you're going to say, some of you, and I know Astanil, if she were here, she would say, this would be her comment. So like what she's not here, let me say the comment for her. Here my instruction to you. My instruction is, I did the 2x2 for you here. I'm going to now give you a 3x3 to do on your own in class. And this is Astanil. Yeah, man, that's how you stay, man. You do the easy one in class, and then after that, I'm not going to give you the hard one for do. But of course, you know, guys, that is not true, right? Agree with me and not Astanil, please. Okay, no answer. So I guess that you're agreeing with me. So,
No, sir.
just working with a one show. All right. So this is a challenge. It's a challenge one for you. I mean, this is like the last question I have on this because it doesn't get any harder than this. So you know how to do the 2x2. I'm challenging you. You know how to write the matrix for the 3x3. You know how to write the matrix for the 3x3. And let me just repeat. The first row is x, the second row is y, the third row is z. The first column is x, the second column is y, the third column is z. You know how to write it, and all the numerators are squiggly square f. So you know how to write the 3x3 matrix. Now, to compute the Hessian matrix for the function x, y, z, here what you need to find. You're going to find f subscript x, f subscript xx, f subscript y, f subscript yy, f subscript z, f subscript zz. Then you are going to also find for me f subscript x, y. You're going to differentiate just like what we did before, just like what we would normally do. F subscript y, sorry, f subscript xy, f subscript yx. Then you're going to say f subscript y, you're going to say f subscript xz, f subscript yx, f subscript yz, f subscript zy, f subscript xz. So what you're doing is so you know you have your x, y, and z, and I want you to listen carefully. Let me say it again. I want you to listen carefully. If you want to jot it down, it's not a problem. You know you're going to find your f subscript x and your xx. You're going to find your y and your yy. And because there's a z in there, you're going to find z and zz. You are going to find now, because remember, we're using our first partials now to do the cross partials. So you're going to find x subscript y. So you're going to find fx subscript y. And you're going to also find f subscript z. So for your first partial, f subscript x, you can't find x again because you already find xx. So you can find xy and you can find xz. Then that's the x done. Then when you move on to the y, you can find yx. You already found yy. Now you can find yz. When you move on to the Z, you can find ZX. You'd have already found ZZ. Then you can find ZY. Does that make any sense?
Yes, sir, boy, I stress you out.
Shamari, did you just say exactly a while ago?
No, sir, Mr. Go over it again.
Okay. Because come in no say you know, go say Mike, you throw big stone after I teach and you go throw big stone same way. So no, man, you tell Mike, he said, no, he can't do the pass them ways there. All right, let's go. Let me say it a different way. Let me say it a different way. So you're gonna find F subscript X, and if you want to write it, you can write it. You're going to find F subscript X, F subscript X, X, F subscript Y, F subscript YY, F subscript Z, F subscript ZZ. So you find the first order partial, and then you're going to find the second order partial, the squares. Then now, we're going to work out the cross order partial. So hear me out for the cross order partial. Remember to find the cross order partial, you're going to only use the first order partial. So we're going to start with F subscript X. So because you've already found, you remember we have X, Y, and Z. You've already found XX. That means you now need to find XY, talk truth.
Do it, sir.
So,
Yeah,
yeah.
man. So you technically, you're going to want, since you find F subscript X, you're going to want to mix them up. No, you're going to want to find F subscript X, X, but you find that already. So you want F subscript X, Y, and then F subscript X, Z. Don't. Anybody seen that yet?
Yeah.
All right, let us look at the Y now. So it's the first order partials alone we're using, in order to get the cross partial. So we're going to cross it up now. And if we say F subscript Y, we're going to find F subscript YX. We're not going to find YY because we find YY already. So we don't need to find YZ, don't it? Yes, no?
Yep.
All right. So tell me now, Chevy, we're going to use the first order partial for F subscript Z. Which one are we going to find when I find the cross order?
ZX.
Very good. ZX. Chevy, would I need to find ZZ now?
No. Oh, we already find that one, sir.
Or we already find the ZZ. What is the next one I need to find now?
ZY.
ZY. That is it. And then we finish. So how many cross order partials have we, how many partials calculation we have?
12 of them, sir.
12 of them. And do you understand now why? So if you get one of the 3x3 matrix, you're going to end up with like a 10 marker because there's more work you're going to have to do. So go ahead. If you don't catch which ones you're supposed to do the ones that, that comes to mind, and then we'll talk about it. I'll project something and we'll talk about it. Anyhow, we're finishing this topic tonight and it's now 11 minutes past 8. We still have lots of time, and this is the last question on it. So when I finish this, we can move into something else. And not belaboring this point. Those who don't come class tonight, corner dark. They will get the recording, and I pray to God that they can follow what is happening. So I'm pausing for about 10 minutes. I am right here. If you have any difficulties, just let me know. I'm just going to mute. I'm right here. Start with your partials. I don't want to project the partials because this is also practice for you doing the partials. Now be careful. If you're finding F subscript X, you're only differentiating X. Finding Z, you're only differentiating Z. On the mark, get set, go.
Sir,
Yes, Mikey.
think I'm done.
Okay, great. How the rest of you stay?
Still working, sir.
How many have you done? How many did Mikey?
All of them, sir.
How many?
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12.
Well, all right. Anybody? Shamari, how many you done so far?
Uh, 6.
Chevy?
8, sir.
Simon?
There's 7.
All right. Mikey, turn 20. Look over the ones that you've done, and again, give the others a chance to finish up and then we just run through it because this one is not bad. All right. Come
Okay.
on, guys. The rest of you, I'm going to give you 3 more minutes. All right, Mikey, look over your resume. I'm not saying that you're wrong with that because I don't know what it is that you get yet. Just look over for me, please, in the meantime.
Finish now, sir.
Good job. So there are two of you still working, Simon and Chevy. Hurry up for me, please. Half a minute more, half a minute more, half a minute more.
All right, sir, I look at the time to look over.
All right.
Make
Always
two-
have to check
you
over,
make
man.
two simple mistake, you know.
Yes, I. Yes, I.
All right, finish, sir.
Finish. Simon,
Yes, sir. Finished.
or finish? All right. Mm. Okay. So let's go. Let's go, let's go, let's go. Let's go, let's go. Okay. So let me hear it. Let me hear it. And how many of you in class? There are 5 of you in class, 4 of you in class. If I do 1, 2, 3, 4. 1, 2, 3, 4. All right. So if I give you 1 each, 1, 2, 3, 4. 1, 2, 3, 4. All right. So this is what I'm gonna do. Starting with, okay, Chevy, I want you to give me fx and fxx. What did you get your values?
All right. 10xy z cube plus 2y cube z. That one is for fx. And fxx, I got 10y z cube.
Is he correct?
Yes, sir.
Shamar, we get agree with him?
Could I ask him to repeat the first term?
10xy z cube plus 2y cube z, and
Yeah.
the xx is 10y z cube.
Ah, yes, sir, that's what I got.
Simon,
Yes, sir.
all right, good. I heard Mikey that says yes. Okay, he's correct. Mikey, the next one is yours. Y and YY.
All right, so for the y, I got 5x squared z cube plus 6xy squared z minus 8yz squared. And for the yy, I have 12xyz minus 8z squared.
Is he correct?
Yes, sir.
Thank you, Shamari. Chevy and Simon, do you agree with him?
Yes, sir.
Yeah, yes, sir.
Okay, very good. I agree as well. Simon, Z and ZZ are yearns. Go ahead.
Sir, 15x squared y z squared plus 2xy3 minus 8y squared z. Then for zz, 30xy squared, wait, no, 30x squared y z minus 8y squared.
Do you agree with Simon?
Yes, sir.
Yes, sir.
Chevy?
Yes, sir.
Okay. Okay, good. I agree with him. All right, Shamari. Haha. Why, sir, would I do this though? Anyhow, fxy. I want you to listen. I want you to do xy and xz. xy and xz.
All right, sir. For XY, I got 10xz cubed plus 6y squared z. And for XZ, I got 30xyz squared plus 2y cubed.
Is Shamari correct?
Yes, sir.
That's what I had.
Yes, sir.
All right, good. Very nice. Guys, I'm very encouraged. Very encouraged. Very, very encouraged. You see, after the exam here, anybody who passed the course, we're going to go on one little excursion. And this excursion is going to be sponsored by Shamari, Chevy, Mikey, and Simon. I don't hear amen, you know.
Amen, sir.
Okay, all right, good. Right? And then now, Shamari, I don't hear no amen from you yet, sir. Amen.
Yeah.
Comfy, you know, Shamari, I go comfy, you know. It's from there. Chevy, why so silent?
Well, sir, may I listen, sir. May I listen?
Yeah, I know it's all right, man. I said nothing to you either. All right, do me a favor. So that's very good, guys. Very good. Now I have 4 more, and each of you going to get a piece of it. So I want you to listen. Chevy, I want you to give me fyx. Fyx. What do you got for fyx?
10xz cubed plus 6y squared z.
Is he correct?
Yes, sir.
All right, good job. Shamari, Simon.
Yes, sir.
Do you agree?
Yes, sir, I agree.
Okay,
Yes, sir.
good. Good. All right, Mikey. YZ is yours.
15x squared z squared plus 6xy squared minus 16yz.
Is he correct?
Yes, sir.
Yes, sir.
Yes, sir.
All right, good job. I'm also agreeing. Very nice. Simon, ZX is yours.
Sir, zx 30xyz squared plus 2y cubed.
Is he correct?
Yes, sir.
Yes, sir.
He's correct, sir.
Yeah, but
Am I-
me not hear Shamari yet.
FZY, I got 15x squared z squared plus 6xy squared minus 16yz.
All right, guys. Did you get that?
Yes, sir.
Very
Yes,
nice.
sir.
Very nice. Guys, very encouraged. This could be maybe the best class we've had since the semester started. Very, very nice. All right. Now, do you remember the 3x3 matrix of the Hessian? We did that earlier. And that is it. That's a 3x3 matrix. Remember we said, just as a review, as a quick review, remember we said that going across is my x's, then my y's, and then my z's. Going down is going to be my x, going down is my y, going down is my z. So when you go across, you're you're starting off with the x's first. That we have x, see here, squiddly x, squiddly x, squiddly x first. And I go down, there's another squiddly x, I call it squiddly x squared. I go down, I'm going to have squiddly y, then a squiddly z. You notice all of down here says squiddly z. All of down here says squiddly y. All of down here says squiddly x. All across here says start off with squiddly x. All across here says start off with squiddly y. And all across here start off with squiddly z. The point I was making earlier is A11, A12, A13, A21, A22, A23, A31, A32, A33 are elements or entries that are in a fixed position in my 3x3 matrix. Similarly, all of these are in a fixed position. So don't give me this one for this one. No. They're in a fixed position for my 3x3. So when I do all of that now, I'm going to arrange all of what I would have gotten. Remember now, the first partials are not going to be part of the calculation. So you have 12. The first partials are not going to be part of the calculation. Remember, the first partials are so 1, 2, 3, not going to be a part of it. All right? Now, watch me. I color coded it. Are you seeing the screen?
Yes, sir.
All right. So the first F subscript X, Y, and Z not going to be part. So we have 12, we take out 12, we have 9 left. We have 9 left, but these two are the same. So we have 8 left. Then these two are the same. So we have 7 left. And these two are the same. So we have 6 left, right? What am I saying is, I arranged it to show you. Remember I was saying to you, those in the main diagonal are going to be different. But these two here are going to be the same. The one down here and the one across here are going to be the same. And them two here are going to be the same. Do you agree with that? Can you see that?
Yes, sir.
Yeah.
Yeah, man. Mikey, this one is yours. You remember you were saying to me that my substitution is not correct because of whatever the situation is, green and so forth. Say I use a different color code here now, pink, red, and blue. Would have no pink here, so up here, so. So all we are doing is putting our X to be pink, or Y to be red, and our Z to be 2. Do me a favor. I can do it, but once I don't want to do it, I want you to do it. I want you to evaluate now for me what the final matrix is going to look like, and that will be the end of the question. Evaluate for me what the final matrix is going to look like, and that will be the end of the question. 5 minutes. Start now. Let me hear what to say. Muting.
Finished, sir.
Nice.
Finished.
Mhm.
I'm not sure. I trust the answer is still in, but
Well, should we get it right? Simon.
Yes, sir. Finish.
All right. Shamari, give me the first column, please.
80, 12, 2.
Good. Simon, give me the first row, please.
Sir, the first row, 80, 12. Wait, hold on. Sorry, it's 80, 12, 2. Yeah, it's the same thing.
Okay, let it have to the same thing. All right, cool. Mikey, give me the second column, please.
got 12, negative 32, negative 32.
Chevy, give me the second row.
12, negative 32, negative 32.
Shamari, give me the third column.
2, negative 32, 8.
All right. Oh no, I get it. Oh no.
8 or negative 8.
Negative 8.
Oh.
There you go.
Negative 8.
So wondering about all of the negatives, because I never to trust it.
Yes, I. Very good, guys. We started and finished this topic in class today. Very, very good. I have only 2 of them for you for homework. Only 2 I have for you for homework. And I need to go do my homework as well. And those are the. So I'm giving a 2 by 2. And I'm giving a 3 by 3. 1 each for homework. You did very well in class today. I couldn't ask for a better class. Couldn't ask for a better class today. So here what now? You see, those who don't come class, yours is going to be the responsibility to explain to them, because it's a Monday, God's willing. Or let me tell you, let me not say Monday, God's willing. Next week, in addition to the mid semester, I would love to go through. Oh, sorry. Can you screenshot this for me, please? Because I want to move my screen. Screenshot that for me. That's your homework.
Yes, sir. When you finish, you can just scroll back up. Let me see the call it the squiddly.
Okay, sure, no
please.
problem. Next week, I want to start and finish Lagrange multipliers. Lagrange multipliers again is multivariable functions. That should be the last note. That should be the second to last thing when with multivariable functions. It has some resemblance to critical points. I say this to say to you that we've already done critical points, so understanding it shouldn't be a problem. So just like, oh, we don't know how to do the partials already for this, and it took us easy. Normally, if I never taught partials before, I'd have to teach partials, so I couldn't touch onto Hessian Matrix. To start Hessian and finish it. So again, the Lagrange multipliers. And after the Lagrange multipliers, I'm going to then move into the final multivariable function I'm going to look at is some multivariable integration. And the multivariable integration are, or double and triple integration. The double integration will be, of course, the x and y, and your triple integration will be x, y, and z. So by next week, I'm saying this because I want to work out a little thing. Today's the 12th. Rockstone, but we don't have much time. No, this serious. We have 2 weeks left for the semester to finish, really. Because I really want to give you off from the 29th. I wouldn't want to have class in that last week. If you guys have a difficulty and want us to meet, I have no problem. But my intention for now is to finish the syllabus in a way that we don't have to meet that week of the 29th of April, that Monday, the 30th of April, the 1st of May, 2nd of May, 3rd of May. I want to give you those times, those days off for your own preparations. And then exam begins on the 6th of May. It's the 6th of May, don't?
Yes, sir.
Right. So technically I have 2 weeks. So my plan is, if I can finish off for next week, and then use that week of the 22nd for my own revision and question and answers and so forth and so on. Yeah. Jesus, I keep forgetting, Lord, help me forget.
So me I begin to stress you upon the mid semester.
I won't. I keep forgetting, Lord, I need to. Yeah, I won't. Students, let me tell you something. I'm feeling very encouraged for the calculus 2 this semester. Very encouraged for the calculus 2, but not lie to you. You guys let me feel like on a Friday evening when it's supposed to be my time. And of course, you say, sir, meetings are to circle me like my Friday evening. Yeah, we sacrifice together. That's the point. It's not just me alone. All of us sacrifice together to be here. And I'm very encouraged. It makes me feel, outside of the times when I'm not well and I take heavy medication and I fall asleep. I was saying today in the WhatsApp group that particularly this term was very rough for me. 3 times I caught the flu. And I guess because it's heavy work. And on top of that, after I spoke to you this morning, or yesterday, whenever time I sent in the group, I was given yet another class for this semester, a group that is just beginning, yet another. But I should be fine because we're wrapping up really. So after these 2 weeks, I should be able to see my way through. Students, you're in a good position. No. There are a few of you in this class that received, and you know yourself, B's from me in calculus 1. I want to see which one of you bad enough not to give me an A for this semester. Sir, I don't like the sound of that. It sounds like you're threatening us. Absolutely. And I'm so bold to say it in a recording that I'm going to send out to you, that you can carry to the pulpit and say the teacher threatened us in class. Students, I need to see some A's this semester. Now, there are some of you who would have received C's in calculus 1. I do not want to see any C for Calculus 2. I'm tired of seeing the C's. Those of you who have your C's, you're in a good position this semester to receive your A's. I would love if you all pass the exam with your A's. If you bucket 2 and fall down, give me a B minus. I don't want to see this semester. I want the quality of the grades to go up for this semester. Please and thanks. You're in a good position. Those of you who need to start your EDUCAS off this weekend, we have 2 weeks left. Students, I'm getting off this calculus to the first something out of my marking. I am marking your papers first, and as soon as I mark, I'm extracting the grade. Ask the calculus 1 students. Calculus 2, those who came over for calculus from calculus 1, ask them. I did not tarry. The exam was a Friday, and by the Monday I was finished. They did not see their grades until about the Wednesday, Thursday, thereabout. But I was finished marking, extracted the grades and everything. I didn't have any time to say, okay, Mr. Shan, finish me this piece of work. No, it must be done before the semester ends. So I say this to say to you, those of you who are playing around, try and commit your time to completing the EDUCAS of this weekend, please. Your mid-semester is next week. I won't kill you for the mid-semester, but what I expect of you for the mid-semester is excellent work. I will need time to mark so I can send off the results to you. Big up on yourself. Have a good weekend. We'll talk. Oh, no. Mikey said that he wanted to see something. What you wanted to see, Mikey?
Yeah, yes, sir. So I know you're probably tired and thing, but
No, it's all right.
so the recording, I think it was from the last one and this one. Sir, we can get it by tomorrow, like tomorrow evening, because I want to use the Saturday night and Sunday to go over them.
Can anybody respond to Mikey, please? Nobody? The recording for last class, Mikey, is already up.
Oh, it's already up. Okay,
Long
sir.
time. So the only recording that is supposed to be done is this one.
This one. Okay, sir.
Big up yourself.
All right, sir.
Take care.